All right, I think that's live. I'm gonna go ahead and get started. Hello and welcome in. Happy Friday. What I'm doing is hosting live stream for math tutoring. So if you're out there and you need help with your math, you're welcome to come join me and post problems in my chat. I am going to go ahead and, I was originally gonna do a system with Gauss-Jordan again, but what I've decided to do is work on this same system, and I'm going to just solve it using just regular algebra and see if I can do it. I don't know. I worked on it a little bit, and I didn't really give myself enough time to solve it, and then I came up with another idea of something I could do, and so it's like the second attempt of trying to solve it. I haven't been successful yet. So hopefully I am able to solve it, and that would be ideal and not very much time because really it's been a long week, and so I kind of, I don't really want to have a solid hour of math on the board tonight. I'm hoping to, see if we can get it done. So we're just going to get started and just try to finish this problem, see if I can solve it algebraically, and if not, oh well, and we'll call it good for the week. And then we'll just see what I'm gonna do next. And if I'm gonna put away matrices and move on, I really haven't decided yet. But anyway, matrices are not easy to do. It's a lot of work, and so I think that it's probably an off-putting subject for a lot of people. Just simple fact that nowadays we have computers that do our work for us, so it's kind of impractical. Anyway, but I also like the creative thinking, creative problem solving process is something I enjoy. So I just want to see if I could do it, and it's a challenge. So we already have this system's solution here, and the way it's read is W, X, Y, Z. It's an ordered pair, and this one is it's a linear because of all of these variables that we have are all raised to the first power. There's not any squares or cubes or anything like that. It's just a system of linear equations with 4 different unknowns. And so each one of these variables basically represents a unique unknown. So when I'm solving and I'm thinking about a method of solving, what I want to do is I want to use and I'm going to go ahead and erase the type because this is substitution and elimination. And what I'm doing is I'm using a combination of both methods. So when you solve a linear system and you only have 2 unknowns, really you can get away with either substitution or elimination. But you really end up substituting anyway. So it's really a combination of both methods. When you get into 3 variable, 4 variable, you're going to have to employ a combination of both, say, elimination and substitution, most likely. My favorite, if I had to pick one, and I would say substitution, because that one, it just seems like it's much more straightforward. You can almost always make a substitution. But anyway, what I'm thinking of doing, my second attempt here, is trying to use the fact that 2w minus 3x equals 8, because I can solve that for either w or x. And I can't substitute twice, obviously, but I could make one substitution and eliminate either w or x out of both of these equations. And then I could add the y values, eliminate y, and maybe possibly, that would end up with z equals. So I was thinking about maybe possibly just taking this value and plugging it into all three equations and seeing what happens. So that's probably what I'm going to do first. Okay, so anyway, we'll just see how this goes. So we'll just start with taking this one and solving it. And I'm going to solve it for, I'll solve it for x. So that'll be 2. Ooh, I'm going to solve it. Yeah, we'll see how it goes. 2w minus 3x equals 8. Yeah, so subtracting 2w from each side, you get negative 3x equals 8. I'll list the variable in front. Hang on. Negative 2w plus 8. And then, oh, this is going to be ugly. All right, I don't want to do that. Not yet. We'll go ahead and define it. 3x minus 2 thirds x minus negative 3. So we'll go ahead and solve for x, but we're going to do another step first. I didn't realize that we're going to deal with fractions already soon on. We'll just see how it goes. So x equals w minus 8 thirds. That's how that ends up. So I'm going to box this and come back to it later. Because if I make a substitution here, let's see what happens. So I have x, then I'll have w, y, c. All right, what I'm going to do now is I'm going to take and add these two equations. So you got w plus 3x minus y minus 4z equal negative 12. And I've got w minus x plus y plus 2z equal 8. Adding, you just literally add like terms, you get 2w plus 2x. Y's go 0, they're additive inverses. And then you got minus 4 minus 2 is negative 2z. And that equals negative 12 plus 8 is negative 4. All right. So we've got this now. Let's box this. So now I have essentially, if I plug in x here, I have w and z. And then I can plug in the other one here. All right, let's do that. Let's plug in x into the top one. That's a good idea. So we'll do it here. 3w plus 6x minus 3z equal 3. And just making a substitution of 3w plus 6. We're just plugging in here. What x is equal to w minus 8 thirds minus 3z equal 3. And then that's going to be 3w plus, use distributive property, 6w. Let's see. And that's 2 times 8. That's negative 16. Minus 3z equal 3. So 6 plus 3 is 9w minus 3z. We're We're gonna add 16 to both sides. That's gonna give me, is that 19? 16 plus 3 is 19. All right, let's box that. Go back over here and plug in. Wait a second, we haven't made the substitution yet, so we can go ahead and do that now. We're gonna make this one. We're gonna make this one plug in for x here. So we'll have, that's 2w. Yeah, that's right. Get out of the way. Plus 2 times, right here, we're going to make that substitution, what x is equal to, w minus 8/3 minus 2z, and that equals -4. That does not work 4. Okay. And then use the distributive property here and simplify, combining like terms. That's 2 times w is 2w, 2 times 8. That's going to be 16/3. And that can't reduce yet. So we got 2z equals -4. All right, 2w plus 2w is 4w. And then minus 2z. And that's going to equal, we're going to add 16/3 to both sides. So we got 16/3 and then -4. So we're going to combine these like terms, get a common denominator. And then see 4 times 3 is 12. So we end up with 16 minus 12, it's 4/3. So 4/3. You can't really avoid fractions because all of the solutions have fractions here. So that's kind of what makes me think dealing with a variable that's a fraction. Early on might be the ticket here. All right, so now I have these 2 equations. Okay, and they both have the same. So now what I can do is I can make like a subsystem now. So here's my subsystem of 2 variables. So we've got 9w minus 3z equal 19. And we've got 4w minus 2z that equals 4/3. And then what I'm going to do is I'm going to multiply the top equation by a -2 and the bottom equation by 3. Just employing reciprocals here. And then I'm going to eliminate, add the equations and eliminate z. So -2 times 9 is -18w. -2 times -3 is positive 6z. And 2 times 19, that's 38. And it's a negative. And then repeat that process here, multiplying everything by 3, you're going to get 12w minus 6z. And that equals, well, those will cancel, so that equals 4. All right, perfect. So now when we add the equations using that elimination method, we're going to lose the variable z, and we'll be able to solve for w. So it's -18 plus 12, that's going to be -6w. And then 0, that equals 38 minus 4 is -34. So you're going to divide off -6. See how far this reduces down. So we got W equals, let's see, 34 divided by 2, 17 times 2 times -1. Or is that, wait a second, 34. I don't know, maybe I made a mistake in here somewhere because it's supposed to be not 3 in the numerator. So that's 18. Yeah, that's correct. All right, so negative 2 times 3. The 2 are going to cancel. There's a negative 17 over -3. So that would be positive 17 thirds. It's not 17 halves, so I gotta find my mistake real quick, see if I can see it. Dang, it was so close. All right, so I kind of did the math pretty fast. So maybe there's just a minor ticker here somewhere real quick. So this one is 12, -6, and 4. This one is 18, 6, 19 times 2 is 38, 34. Make sure I did this one correctly. Wait. Is that correct? Did I make a mistake here? It's 2, there's a factor of 2 I'm missing here. All right, so I found a mistake. Go fix it real quick. Oh, thank goodness I won't have to rework all of it. I'll just have to fix it here. Myself here, W is not by itself. It's got a factor of 2, so it's 2W divided by 3. So there's my mistake. All right, perfect. It's really nice when you can find it, but you can't always find it. So there's 3 minus 8 thirds. And then I've got to also replace it here as well. So we're recalculate that. It's going to lead to a different mini system. Oh, it's so frustrating when you make some minor mistake like that. It throws the whole problem off. But hopefully one day I'll learn to be more careful. I'm getting a little bit in a hurry here. All right, so let's just do this real quick. So we've got 2W plus 4W divided by 3, and that's minus 16 over 3 minus 2Z, and that equals -4. So now when I add these fractions, get a common denominator, we're going to have 3 times 2 is 6W plus 4W minus 2Z, add 16 thirds to both sides. Let's do it here. That was 16 divided by 3 minus 4 over 1. So this will give me 3. And 16 minus 4 times 4 is 12. That was 4 thirds. Positive 4 thirds. And then we finally have, looks like 10 W over 3 minus 2Z equal 4/3, which is not as pretty, but it's more accurate, it's correct. So repeat that process here. 3W plus 6 times 2W divided by 3 minus 8/3 minus 3Z equals 3. So this is 3W. Use distributive property. 6 times 2 is 12 over 3. And then 6 times 8 is 48 over 3 minus 3Z equal 3. Combining these fractions, getting a common denominator. 3 times 3 is 9W plus 12W minus 3Z. Add 48/3 to both sides. Do it here. 3 plus 48 divided by 3. 9. So 48 plus 9 is 57/3. Okay, good. And then 9 plus 12 is at 21. W. Oh, wait, 9 plus 21 divides 3. That's 7, I think. Or 9 plus 20, wait, 9 plus 12 is 21. Yeah. Minus 3. All right, so 21W equals 7W. Oops, erase that. I don't know if just 57 divided, there's 3 divided 57. Yeah, it does. It's 19. So it's 19. All right, good. So we have these two systems. They're not as bad because at least they both don't have fractions, but they're still, not pretty. Let's go ahead and not circle that. Just do the math right underneath it, save room. I'm going to write this one right below it here. 10W divided by 3 minus 2Z equal 4/3. And then now we're going to do that thing I did last time where I'm trying to make this number the same opposite. So I want them additive inverses here. So I just figure out that I got to multiply this one by 2, or just do -2. And then we're going to multiply this one by negative, or just rather positive 3. Perfect. And then doing that, the first one, you're going to get -14W plus 6Z minus, or equals, rather, and 19 was at -38. And then this one, these 3's will cancel. So that's 10W. And then 3 times 2 is -6Z. And then 3 times 4, these will cancel again. And then that equals 4. Now when you add these two together, you get -4W. And that equals 38. negative 3 plus 4 is negative 34. So dividing off the negative 4 from both sides here, we get W equals 34 divided by 4. And so I'm going to figure out 34 is 17 times 2. And we have 4 is 2 times 2. So it checks out. We got it. We got the solution for W. Perfect. If we did not know the solution, then I mean, it's cool. We actually have it, but just to check. But if we didn't have it, this is one way you could find. Because now all we have to do is take what W is equal to. So let's put over here, W equals 17 halves X, Y, and Z. Now we can take what W is equal to and come in this original equation and figure out what X is. So we have 2W minus 3X equals 8. And then just plugging in 2 times 17 halves minus 3X equal 8. Solving for X now. Got 17, oops, minus 3X equal 8. So then if you subtract 17 from both sides, what's 8 minus 17? Is that 9? Negative 9? So this says negative 3X equals negative 9. Divide off the 3 from both sides, and you get X equals 3, which is correct. Since we have X, so we have, we have W and X, so now we can use the first one to figure out what Z is. So that's 3W plus 6X minus 3Z equal 3. Plugging in both of these unknowns, it's going to give us 3 times 17 halves plus 6 times 3 minus 3Z equal 3. So all we have to do is just figure out, simplify this. 17 times 3 is 51. This is going to be 51 over 2 plus 18 minus 3Z equals 3. Figure out common denominator here. 18 times 2, 36. And it's 51. I'm getting 87. So 87 over 2 minus 3Z equal 3. Right here. 87 over 2 minus 3Z equal 3. Sitting down in the room here. And then we're going to subtract 87 from both sides. It's going to give me negative 3Z equals common denominator 6 minus 87. It looks like is that negative 81 over 2. So let's see what that works. If that works, negative 81 over 2 times negative 1/3. Is that correct? Okay, let's see. So we got 81 is 9 times 9, and that's 2 times 3. So it's going to be 3 times 3 times 9 over 2 times 3. I'm getting 27 halves. Yeah, 27 halves. But isn't that the solution? Oh yeah, that's for Z. Cool. Perfect. So Z is 27 halves. We've got one more to find. And that would be Y. So what we'll do is we'll use the positive Y here. That equation, plug in all of our unknowns. And put this W minus X plus Y plus 2Z equal 8. So we'll plug in 17 halves for W. 2. And then minus X plus Y plus 2 times Z, which is 27 halves, and that equals 8. So we could right away combine those real quick. So that's 2. So we can have minus 2 times 3 is negative 6 plus Y, and then distribute here. 2's cancel, so that's just going to be plus 27 equals 8. 17 minus 6 is 11 halves plus 27. So I'm getting a common denominator. 27 times 2 is 54 plus 11. I'm getting 65 halves here. Just adding those two. And then we're going to subtract off from 8. So we've got 8 over 1. That's a positive, so it's going to be minus 65 halves. 2 times 8 is 16. Perfect. I'm getting 49. 16 minus 65 is 49 over 2, which is Y. So Y equals 49 halves. Perfect. Cool. All right. So I was successful in solving this, and about 30 minutes in. So we're going to go ahead and stop there. And yeah, cool. I didn't know if I'd be able to solve a system for variables algebraically. So I'm glad that worked out. It's been a long week, and I don't know about you, but I'm pretty exhausted. So I am going to go ahead and call it good there. And I will be back next week. Probably be changing my live schedule here soon. So if I have, my diehard fans out there, just be looking towards that. Get some summer hours probably, and then leading into the fall schedule. I'm only going to be able to be doing it probably 1 day a week next fall. So starting in August, I'll have to go down to 1 day a week for a while. But what I'm probably going to do is try to go every other day, possibly. So I'm looking at changing up my schedule a little bit and being a little bit more conservative with my hours for summer. So anyways, thank you for watching my video. And yeah, I hope that you enjoyed it. I hope it wasn't too terribly boring. But yeah, if you have any questions for me or comments, you're welcome to post in the chat. And until then, I'll just sign off there. I'll say bye for now. I will see you next time.